G'day. What we're talking about today is we're looking at kinematics in terms of integration. So when we're talking about kinematics in terms of integration, we're going to be breaking this up into two sections. One, we're going to be looking at distance or displacement and velocity, and then the second one we're going to be looking at velocity and acceleration. So let's get into just an introduction to about how it all works, do some recall, relate this to some information, and then we'll get into some examples. So we've got displacement and velocity with kinetics. So things that you need to remember from when you do kinematics with calculus is that the position is the same thing as when you're finding displacement. So what do I mean by that again is if we are starting at A and we move to B, then I've been displaced by, let's say, 3 units. I've gone from A, I've moved to B, I've been displaced. Also, if we are looking at, we'll look at our distance as well. The distance in this case would be 3 units. If we're looking at displacement, if we went to A and then we moved back and finished at B, then I haven't been displaced at all. I've moved, but I've come back to where I originally stopped. So displacement is where you started to where you finished. And if you finish at the same place that you've started, you haven't been displaced. You haven't actually moved away from that point. Distance is when you have moved away and you've traveled away from that point and back to that point. So in this case, displacement from A to C would be no displacement. But distance from A to C would be 3 units, and another 3 units, so you've travelled those 6 units. So really important to remember that in terms of what displacement means. Initially, again, remember we see initially, that's when time is equal to 0. And what we know about time, because t equals 0, that means time always has to be greater than 0. We can't have negative 0 unless you're Dr. Emmett Brown. All right? That is the only time that you would always worry about this here is when it's initially asking you something, and that's going to help you find your integral C value when t is equal to 0 or when it's initially equal to something else. Okay, you plug that in for y and get your value for x. Change of direction. So when we're changing direction or when we are at rest, we find that when v of t is equal to 0. Okay, so when we did calculus, you had to differentiate to get to v of t, but when it comes to integration, we're going to have to integrate backwards. Or they may give you v of t at the start, and then you integrate to go back to get your displacement. But however, you get your change of direction, and when you have a change of direction, say for instance here, b, that's when we have a root. Okay, so when we find the roots when x equals 0, that's when you have a change of direction. And also when it's asking you to find the maximum, that is when you have v of t is equal to 0. Okay, so let's get into some of the terminology that you're going to come across when we look at displacement and velocity. So the first thing here is, a lot of the times in your textbooks or in questions, they may have s of t. I've gone for x of t just so that way you don't get that mixed up with the integral symbol. So displacement is generally notated as x of t or s of t. To be able to calculate that, a lot of the times when it comes to kinematics and integration, they'll give you the velocity function, and you have to find out your displacement function. And we find that by integrating your velocity function, and that gives you your displacement. We can also find that displacement if we have the values in terms of where we're starting to where we're finishing. If we integrate that, that can give us that answer we're looking for. If not, displacement is starting from where we finished to where we started. So in this case, this would be C, that would be A, and that will tell us how far we've moved. Now, when it comes to velocity and integration, we're working with a time function. What does that mean? That means that the velocity itself in integration can also be used to calculate the distance or the area, the distance you traveled. Okay, which makes kind of sense. You're moving. Okay. when it comes to integration, because we're finding the area underneath a curve, so if we had a graph here, this area from, say, 0 to 5, if we plug that into our velocity function using those upper and lower bounds, the answer is actually the area. And the area is the distance that you have travelled from 0 to 5, which kind of makes sense because you can't get negative area and you can't get negative distance. So therefore, when it comes to the velocity function, we can use your graphics calculator as well to help us work out the exact distance you've travelled. And we can use some algebra that we can do in that next video as well. So what does that mean? Something that I talk to my students a lot about is, well, if we absolute value the velocity function, that means anything is going to be positive. So what do I mean by that? So if I had a graph and it kind of looked like this, and just say, we're not going to worry about the negative because there is no negative, just say we come through here and we have area between these 2 points. Underneath the x-axis, we consider that as a negative answer, but we know that we can't get negative area. So if we add these two answers together by doing a double negative, we get the total area, which tells us that distance that the particle has moved along. By putting this in an absolute value, what it does to the graph is it makes it positive. So when you do try and find the area, because if you try and find the area in the graph where your area is down the bottom here, your calculator will subtract that area away from each other and say, you know what, you've cancelled it out. You've got no area. But if you do the absolute value of the function, then it's going to say, well, you've just said, I don't want anything being less than 0 for x. So everything's got to be above x, which is what we want for area. So therefore we can add both these areas together, area 1 and area 2, and that will give you the total distance. Another thing that you need to look at is the last part is moving left or moving down. If we're moving to the left, then we have negative motion. We're moving away from where we're going. So for instance, in this graph up here again, everything down the bottom here will be moving towards the negative from the root. Where if we had a motion diagram, from this point to this point, we're moving in a negative direction. So moving left or down, we have negative motion. If you're moving right or up, you have positive motion. So we're going to look at a couple of examples in the next couple of videos in terms of using a motion diagram and then using a graphics calculator with the absolute value and algebraically using the absolute value to get that area, just to eradicate those nuisance C's that you're going to be working with. Alrighty. I hope that made sense. A nice introduction to what kinematics with displacement and velocity is. Our next videos we'll just get straight into an example. Cool.